So we've been talking about functions, and today we're going to talk about piecewise function. Now the key word is piece in today's lecture. Parts of functions is what we're going to do. So if you look at the following question, or following command, I guess, graph the function y equals 2, but only when x is greater than or equal to 5. Well, where's x greater than or equal to 5? It's right here. Now I have to graph where y is equal to 2, which means I include that point and graph greater than or equal to 5. That's a line going this way. All right, so pretty easy command. Next, this is more of what the typical piecewise function will look like. It will be 1y equals and several different pieces of a graph. This tells you what the x values are after the when, or sometimes they'll put a semicolon, and this tells you what the y's are going to equal. So this says when x is less than or equal to 4, I'm going to graph y equals 3. So here's 4. Here's y equals 3 less than or equal to. I'm going to go this way. Greater than 4, less than 6, non-inclusive. Y's got to equal 5. So greater than 4 and less than 6, y equals negative 5. Sorry about that. Negative 5. And we go all the way till we get to 6. Not including on either one, so open circle. Finally, x equals 2 when x is greater than or equal to 6. So here's the value of 2 at 6. Fill in the dot. Go to the right. Problem done. Now we're going to throw some linear equations in. Notice again, here are my x values, here are my y values. In this case, I can take and look at 1, plug that in, and say, well, I would be at 7 if I were at 1, but it couldn't be included because it says it's strictly less than 1. And now I have a slope of 2. So if I go down 2 and back 1, a couple of times just for accuracy purposes, I can take and graph that line like so. All right, and then I get a y value of 1 when x is greater than or equal to 1, so that's right here, all the way till I get to greater than or less than or equal to 3, connect the dots. Finally, when x is 3, so here, let's just remind ourselves, I plugged a 1 in and got out a 7. Here I'm going to plug a 3 in and get out a 3. So when x is equal to 3, y is equal to 3, but it can't be included because it says this is only when x is greater than 3. So now I have a slope of negative 1, so I go down 1, over 1 to the right, do that a couple of times, and then I will draw a line to go through that, like so. And there's my piecewise function. Next. So you'll notice in this example that we have two linear functions and x values of 6 for both. One is included though down here and one is not included up here. Still, I'm going to find out where I would be for y if 6 were plugged in. So I'd take f of 6 here. I get 2 is 4, which is 8. And f of 6 here, whoops, f of 6 here, I get negative 3 and 5 is 2. I'm going to go over to 6, up to 8, put an open circle, down to back 3, down to back 3. All fits because I got a y-intercept of 4. Draw the line. Done. Then here I go over to 6 and up 2. Close circle. Negative slope, so down 1 to the right 2. Gonna again draw that line, and I'm good to go. Now we're going to go the other way. We're going to write the equation of this piecewise function, and this is a little different than the ones we've done because they kind of picked up where the other one left off, whereas these have some spaces in the x's, and that can be noticed here. So what I've done is I've given you basically all the x values, and you have to fill in the y. This guy is pretty straightforward because it's just a horizontal line, so this is a constant, okay, and that constant looks to be -1 when x is less than or equal to 3. This also looks pretty easy because it has a slope of 1 and a y-intercept of 1, so that's x plus 1. And this guy has a slope of 2, so I have 2x plus something. I'm going to go right here and say y equals 2x plus b. And I know that this is the point 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. 4, 8. So I know that 4, 8 is on this line. If I put an 8 here and a 4 here, solve for b, b ends up equaling 0. So 2x plus 0, or just 2x, gets that done. And there's my equation for x equal to -3, x between -2 and 2, and x greater than 4. Now I give you nothing and ask you to write the piecewise function for this graph. Now this graph's a little bit different as well because it has no opened circles, just a closed circle. Now for it to be a piecewise function, it has to pass a vertical line test. You can't have the same y value at two different points, all right, in theory, or for two different functions, because then it would be crossing over. So I'm going to take that value where they both meet, which is 3, write that down, and I'm going to put one as less than or equal to, and then one as greater than. Notice what I did there. One is filled in, and one is not. So technically, I'm not putting a filled in circle at the same place for two different graphs. You'll notice they're both linear equations. This one's pretty easy to get, which is corresponding to the x is less than or equal to 3, because I have a y-intercept of 3, and it looks to be a slope of over 1, 2, 3, down 1, 2. So that is up to over 3. Positive slope of 2/3 x. For the next one, I can get the slope pretty easy by counting to where the next value is, which is right here. So that's down 3 and over 2 x. And I'll do what I did on the last problem to find my y-intercept. I'm going to go -3/2 x plus b is equal to y. This is the point 5 and 2. So I'll put a 5, oof, this is not going to be pretty, -3 over 2 times 5 plus b and 2 for y. Let's see, that's going to be 15 over 2 plus b of the negative type is equal to 2. That's 7.5. Bring that over. So b equals, it looks to be 9.5. Like so. So plus, and I'm just going to be consistent. I'm going to go 19 over 2. And that should be my equation. So again, this is a little bit different. We're not asked to graph, we're just asked to find these values. So this is like a function notation calculation. It says find f of 5. Well, I got to decide where I'm going to put this in, because it's not necessarily going to go into each and every one of these y values, because these y values only exist over these x intervals. So when x is less than 5, well, I'm looking to plug in 5, so that's not going to work, because x has got to be less than 5. When x is greater than -5, less than 2, well, that's not going to work either, because 5 is greater than 2. So that means I've got to plug the 5 into this third function. So f of 5 is equal to the absolute value of 5 minus 8, which in this case is 3. Likewise, negative 7, I got to find the interval that works there. So I go back up here and say, is negative 7 less than negative 5? Sure is. So I'm going to go into the first guy and plug negative 7, and I get 3 minus 2 times negative 7. That's going to be 14, and 3 is 17. So there is a basic rundown on your piecewise function, and we'll talk again shortly.